An Introduction to Matrices by Owen, myself, and Izzy. Now, what are the traits of a matrix? An element is an individual item or number on a matrix. A row is a horizontal set of elements represented by the variable m. A column is a vertical set of elements represented by the variable n. Dimensions are the size of a matrix, represented by the variable m being multiplied by the variable n, the number of rows being multiplied by the number of columns. There are different types of matrices defined by different dimensions. A square matrix is when m is equal to n. The number of rows is equal to the number of columns, meaning that the dimensions are square. A rectangular matrix is any matrix in which m does not equal n. The number of rows does not equal the number of columns. A row matrix is a matrix with exactly one row, in which m equals 1. A column matrix is a matrix with exactly one column, in which n equals 1.
How do you add and subtract matrices? Well, matrices of different dimensions cannot be added or subtracted. So, for example, if the matrix is 2 by 2 and you want to add it to a 3 by 3, you can. So, in our little example here, we have a 3 by 3 and a 3 by 3 means you can add it. For addition and subtraction, all you have to do is find numbers on the same dimension and column. For example, 4 and 4 here on the top left, and add them together. So, for example, 8 multiplied by 2 equals 400, and we keep going. So, 2 plus 2 on the top middle is 4, 1 plus 1 is 2, so on to the 4th, and then you get this equation matrix. If you want to subtract, all you do is the reverse order. So 4 minus 4 is 0, 2 minus 2 0, so all these would end up being 0, but just simple operation.
Multiplication. To multiply a matrix by a single value, simply multiply each element within the matrix by that value, as shown below. Multiplication between matrices. To multiply two matrices by each other, the number of columns of A, also known as the variable n, must be equivalent to the number of rows of B. Matrix A has dimensions m times n. Matrix B has the variable n times p. They must share the variable n. The product, matrix C, would have dimensions m times p, number of rows of A, and the number of columns of B. Now let's begin going through the process of multiplying two matrices by each other. You must take all of the elements of the first row of matrix A and multiply them by all of the elements of the first column of matrix B. The sum of the product will get you the first element of matrix C. You repeat these steps, multiplying the first row of matrix A by the second and third columns of matrix B. You repeat this process, multiplying all of the elements of the rows of matrix A by the elements of the columns in matrix B. This will get you all of the elements within matrix C, the product. The entire process and product can be seen below.